Hello and welcome to Postgres FM, a weekly show about all things PostgreSQL. My name is Michael, I'm founder of PG Mustard, and I'm joined as usual by Nick, founder of Postgres AI. Hey Nick.
Hi Michael.
And today we have a special guest. We have Harry Brundage from Gadget, co-founder and CTO there. Hey Harry, thanks for joining us.
Thanks so much for having me on. I'm happy to be here.
It is our pleasure. So you've been doing some cool things with Postgres for a while. Recently blogged about a zero downtime upgrade, but there's a ton of other things we wanted to talk with you about as well. Where would you like to start?
Yeah, I'd love to tell you about this zero downtime upgrade, just because, I don't know, it's like a point of pride of mine, I guess. It's always so frustrating to me when I get an email from one of my providers. It's like, hey, Sunday at 2 p.m., we're going to be down for 30 minutes. Like, hope that's okay. So yeah, Gadget's an infrastructure provider. Like the developers who use us for mission critical apps. So we just try to take it more seriously than that and like not, disappear. So yeah, we did a zero downtime upgrade with the help of Postgres.ai and Nick. Thank you so much for your help, Nick. What a treat.
Thank you for trusting us because, we did it with other companies, and always like in the beginning, I might hear pushback because understanding how much work it's needed there, because it's far from being well automated. It should be in Postgres and it's improving, but yeah.
Not quite yet.
Yeah. So you did this journey, and thank you for not stopping.
Absolutely. Yeah.
Great
So
accomplishment.
it was a lot of work. It was. Yeah.
Yeah.
I think too, it's like, to me, it just kind of feels like something that should be built into the managed providers.
Yeah.
Like, I'm kind of surprised that so few of them have it. I think the only one I could find that has like true zero downtime is PlanetScale. But
For Postgres?
the GCP options, I don't know about the new Postgres one. I guess I know they have it for MySQL, but not for Postgres yet. Eh?
For MySQL, yeah, I think so. I don't know details, but for Postgres, I don't see yet anywhere this thing.
But again, like, what the heck? Like, aren't as an industry, shouldn't this have been a thing we kind of like solved 20 years ago and never looked back? I don't understand.
Yeah. And there's no AI needed there. It's just pure automation. That's it.
Yeah, terrifying button to press.
I think what happens is that it should be automated more in Postgres itself, and most managed platforms like RDS and others, they just sit on the fence. Well, I know they work and do it, but they don't want to automate things outside Postgres too much. For example, Analyze, right? Analyze is not automated. You always forget about this. And they don't automate it, and they just put it in documentation on shoulders of users. Now it's time to run Analyze. And I started like asking around like maybe a couple of years ago, why, 1 year ago. And then, okay, Postgres 18 should be out next week, right? Finally, statistics will be, dump restore of statistics will be fully automated, so they will just exclude this from their how-to manual, right?
Right.
So this is an example. Things should be inside Postgres, but I think still they should automate much better.
Indeed.
Not waiting for Postgres itself. Yeah. Anyway, I'm with you here, 100%.
I'm glad. What I was going to say is I've always attributed it or the absence of something like a true zero downtime major version upgrade to the fact that it's like more than just Postgres that you need to pull it off, right? Like you need a connection pooler or a proxy or something in front of it sitting outside the system, and you need a bunch of tight coordination between that proxy and the rest of the system to kind of orchestrate it all. And so like I know, at least on our previous Postgres provider, like they ran the PG Pooler on the same VM as Postgres itself. And so like they're kind of hamstrung by the architecture where they can't have this piece that lives outside that can talk to two at once, whereas we self-hosted our bouncers for exactly this reason and can kind of do it all and orchestrate it all. And it's like, sucks to self-host it, but gets you that architectural flexibility. We needed that.
Yeah, and PG Browser supports PostgreSQL, which helps you achieve zero downtime.
Absolutely. Yeah. We're maybe nuts too, and we run our PG bouncers in K8s and like do the whole, rolling restart and whatever. And it's turned out to be I think an okay choice. Like, I think a lot of people maybe shy away from that because it's sort of super stateful, super critical. Maybe this is a pet, not a cattle. But we did it in K8s just because that's where the rest of our compute runs, and it's like easy to sort of bin pack and share it all. It actually really saved our butts recently because we're paying a lot for intrazonal network transit to our databases. Specifically, like once from our application pod to the bouncer, and then again from the bouncer to the database. And because the bouncer was in K8s, we could turn on the handy dandy like prefer zone local network routing configurations and kind of have the application pod go to a zone local bouncer and then to the database. And I think were we outside of K8s, that would have been a lot more annoying to kind of like teach all the routing to be able to do the right thing. Nick, you look scared. You look skeptical.
No, I'm just thinking this is also a job for database platform, I think, to take care of such things. So yeah, and I know like RDS has RDS proxy, but it doesn't have it has cool features PG Bouncer doesn't, but it also lacks cool features PG Bouncer has. So it's a
right.
zoo, and and I think pause resume is a wonderful feature. Still,
absolutely.
to emphasize it.
I was going to ask about your PG Bouncer setup actually, because your blog post on the upgrade is really cool and goes into good detail on the actual upgrade process. But you didn't talk much about your PG Bouncer setup and like how many you're running, and like do all of your application stuff go through that, or does any of it skip it going to the data? Like, is there anything interesting about that you wanted to share with people?
Good question. I have two interesting tidbits. The first is I think our PG Bouncer deployment's a bit weird, and then we have 9 instances.
Interesting.
And we take our kind of total connection count where we're targeting 400 kind of server-side connections and split that up over 9. And the reason for that is that same K8s network-aware routing thing where the kind of up until very recent versions of Kubernetes, you needed 3 endpoints per availability zone for the network-aware routing to kick in. So we had to use a minimum of 9. And initially we were really skeptical about that because it seems kind of bad, right? Instead of having like, say, 1 or 2 buckets of a lot of connections, we were kind of brokering them fairly. You have many small buckets and you could get kind of weird inefficiencies. But it didn't come to pass where that bit us. It seemed actually okay in the end. And what I like about it is we have a lot of CPU headroom, right? Like PG Bouncer, I think, is still largely single-threaded. I don't know the innermost details of it, but we're using the fancy new prepared statement stuff within it. And so I'm kind of happy that I can give it 9 cores instead of, 2 or 4 or something like that, and kind of be like, take as much as you need.
Yeah, nice. Always good to have headroom.
Yeah.
Cool. Anything else about the upgrade which bits were most scary when Nick came to you with the proposed plan? You said the pushing the button. Is it kind of because it's single direction, or did you have a rollback plan?
Good question. We had a rollback plan, but it was written rather than tested because we sort of like. So the way that we pulled it out, or the way that we kind of built the whole thing, is we built a temporal workflow. So we're like huge fans of temporal. Very easy to kind of script something like this. And the reason why we did this is because it lets us get all the nice kind of retries and item potency stuff for free, where we get to write in a somewhat failure oblivious way. And we wrote our workflow to have like a dry run capability where we would do all but the very last step. So we would go to do everything where we like prepared the new host, kind of replicated the data, made sure we were caught up, did the PG Bouncer pause, and then we just wouldn't kind of reload the config or change over, and we just do a resume, and kind of everything would keep on going sort of as it was. And so the terrifying part is we just never actually done the middle thing, and we weren't really sure, like, here's how we can test this, other than like standing up a whole parallel set of infrastructure, which we were like, I'm not even sure that will prove this one will work, right? Like, it just in my admittedly still limited lifespan, like the things that go wrong are always the things you didn't foresee, right? So it's like we dry runned it 1 million times, found all the things we could foresee, and then it was like the spooky,
Yeah, so it's really like it's impossible to test switchover in production. But I wanted to emphasize it's possible to test everything before that, and it's great.
Yeah.
Like, because this is beauty of this procedure, you like create the whole cluster which is running already a new version. You like see it's working. You can touch it and it's great, like and so on. But yeah, I agree. The scariest part is switch over how to test it properly. Of course, it was tested in non-production, right? But it's different. So here we just need to jump at some point. Yeah.
Exactly. It was the best kind of jump where it was like a big meeting that we were all like scared of. We all like sat down. Nick was on the phone and it was over in like 7 minutes. Where it was like, oh, well, guess it worked. Like all the numbers look good.
Yeah.
Like, yeah, that's it. Onwards, So I feel fortunate to work with a team where, that was how it went as opposed to like us screaming around like chickens with their heads cut
and I
off
wanted
for the next
to
hour.
thank you for this, emphasizing that you use this temporal framework, because we, like PostgreSCI, we're always big fans of Go, and we like developed using Go a lot of stuff. But recently, our team, we have a few Python guys right now, and I just envision that probably we'll learn from you in this experience as well, and do some stuff with temporal as well. So thank you for emphasizing.
Yeah, we're heavy users of it. We use it for these kinds of like systems administration tasks or like behind the scenes maintenance workflows, but we use it for a lot of other stuff too. Like Gadget is mostly used today by people building Shopify apps, and when you build Shopify apps, you have to receive a metric shit ton of webhooks. And so the Gadget has like a background kind of queuing system that knows how to take a webhook and process it later or process it with retries or whatever. And so each one of those is a temporal workflow for us. And so we're doing, I don't know, something like 3K, 4K temporal state transitions per second, also backed by Postgres in this like big ass temporal cluster. And that's something I never ever want to have to try to build myself. Like it's so complicated and nasty and, fun for some.
You mentioned in the post also that sharding was on your to-do list.
Yes.
You mentioned though you're using a different database for that now, like AlloyDB specifically, I think, for the new setup. But you said it was just for the user data. What's the separation there with like Shopify? Is it the data of the Shopify apps, for example?
Yeah. So Gadget is like a general purpose app development platform. So if you want to make a to-do list tracker or a ChatGPT clone or a Shopify app, you can sign up for Gadget and you get kind of like a full stack dev environment. So you get a place to run kind of back-end code. It's all JavaScript, TypeScript. You get a database or a sort of virtual slice of a database to store back-end data. You get a front-end and React and whatever, and you're off to the races. You write back-end code, you write front-end code, you define your data models, you transact, so on and so forth. And then the Shopify part comes in where we kind of have a managed API connection to Shopify, where we'll do the OAuth and the webhooks and sync the historical data, et cetera, et cetera. So like many infrastructure providers, we have a control plane and a data plane. The control plane stores like our list of users, our kind of who has what access to what app, so on and so forth. And then the data plane is the actual app's data. Like this app has a to-do model that stores, this many to-dos. This app has the Shopify product model and, stores this many Shopify products. So when we started, we just stuck those in the same Postgres. Yeah. And then that Postgres got too big. And so this major version upgrade kind of precipitated splitting the control plane and the data plane, which I think is like a pretty obvious best practice.
When you say too big, by which metric? Like where was the bottleneck coming from?
Good question. So we had about 8 terabytes of data in the one instance. Our disk was 8 terabytes big and we were at 6 or something like that, 6.5. And we're like, okay, this is scary. Like we got to figure out the next thing. And we were on PG-13, which was end of life long ago. And so we needed to do the upgrade, and we just wanted kind of a better roadmap for how we were going to deal with growth. Because Gadget has lots of these e-commerce customers, BFCM is always a quote fun unquote time for us, and like we'll see probably this year like a 4x traffic increase and like a 4x database QPS increase, and so that means like we kind of need to be ready for a 4xing of a database CPU, and our provider at the time, it didn't sell a big enough one. So we were kind of like, we have to do the horizontal shard or scaling sort of journey. So what we did is we sharded in order to move the bulk of that 6 terabytes out into sort of newer instances that had much more room to grow, leaving only the sort of reasonably sized control plane left over to do this major version upgrade. And it simplified a few of the steps of this zero downtime major version upgrade because we didn't have to replay 6 terabytes worth of stuff on the new instance.
Yeah, makes sense. So, but why not stick with the existing provider for those shards?
2 reasons, or 3 reasons. The first is we're Google Shop and we get good pricing from Google. The second is Google claims up to a 4x TPS increase with AlloyDB. Like, I like Google and I don't want to poo-poo them. I'm not sure I've ever seen it actually hit 4x, but we did see at least a 1.5x kind of TPS increase without really much config change or tuning or whatever. I can't even say if it's actually the same CPUs like under the hood, you know what I mean? I don't know what the initial provider was using, but the instance was faster for the same price, so that was nice. And then the other big thing with Alloy is you don't pay intrazonal network transit fees. It's not like a normal VM. I present that without comment to the anti-competitive forces that may or may not be listening. But yeah, it's free networking to the Alloy instance. Whereas like if you're, Avon or Crunchy or whatever, and you run instances, like your customers have to pay from 2 out of the 3 zones just to talk to it, so that sucks. And then the second thing is you don't pay for replica storage. It's a split storage compute sort of setup where the disk is this sort of auto-scaled elastic fancy log storage service thing, and then you pay for your nodes that kind of read and write from that shared tier, but you don't pay n times, you pay once. So it's like 40-ish cents a gigabyte, which is like more expensive than like say a big fat EBS volume, but not that much more. And so if you're running like a lot of replicas, it ends up being cheaper storage-wise, and you don't have like all the nasty I/O spikes from backups or any of that stuff.
Cool.
And unlike Aurora, I don't see the hidden cost with Aurora usually I/O costs.
Yeah, no I/O costs.
Yeah, that's interesting.
So our database build came out to be about the same as a pretty classic like GCP VM with, they're not EBS in GCP, but like fat kind of SSD volumes backing it. And we save money on the networking, we save money on not having to pay for storage again for the replicas, and we deleted our like I/O spike for the backups problem.
That's interesting comparison. So we even don't talk about features like this column store or raw store. We don't even without that, just direct comparison. Interesting.
Yeah, we intend to make use of that column store. Like, I'm skeptical. I used to work on sort of like the big data warehousing team at Shopify when I worked there, and like I just don't really believe that you can force Postgres to do the kind of like super wide throughput stuff you need for crazy scale analytics, but you can definitely get pretty far with it. You know what I mean? So my guess is like some of our operational reporting use cases where you're traversing 500,000, 1 million rows to answer a query on a read replica with this column store is going to be fine, but in the like billion, 10 billion scale, I think purpose-built analytics databases still should exist.
We've had a few of those conversations recently.
I'm sure.
I had one more boring question on the major
Please.
version upgrade before we move on to more interesting things. It looks like you're on Crunchydata. You were on Crunchydata before for the control plane stuff, and are going to be again for the upgrade.
Yep.
But you only upgraded, I think, from 13, which, by the way, you're a bit harsh on yourself. I don't think it's quite yet out of support. I think it's like
oh really?
In a few
months, good for me.
Couple of months' time, that'll be out of support. But you only moved to 15, and I think Crunchy have always been very good at supporting the latest versions. So probably 17's available. So why not? Like, why 15, not 16 or 17?
Yes, Crunchy has been great at that kind of thing. I think the main reason was, shoot, you know what? I don't even remember.
Maybe Nick knows.
I also don't remember. I remember that Crunchy had different end-of-life dates somehow. Crunchy Bridge had different dates.
Yeah, they deprecate support, or they stop sort of long-term support before the full-on end of the kind of core support. But they, in fairness to them, they gave us extreme advanced warning, and we knew it was coming for a long time, and they supported it, for 4 years or whatever, which is, I think, pretty good. I don't remember. I think it might have been a desire to keep the versions homogeneous across all our instances.
Sure.
And for really silly reasons, the Alloy shards that we stood up were stuck on 15 and couldn't be newer.
Yes, that would explain it. So Alloy, I think because it's a fork and it's probably quite a hard to maintain fork, I don't think they're as good at keeping up with the major versions. So there's a good chance you wouldn't even have the option of going to 16 or 17 on there. I don't know for
That's
sure.
correct. That's correct. At the time, 16 was GA and 17 wasn't even out yet. Now 17 is out, but it's still in preview. Like, it's not, shouldn't run production workloads on Alloy 17. But the weirdest thing was we wanted to go to 16, but they just don't have PG Squeeze support on their 16 version. They have it on 15 and they have it on 17, but not on 16, and couldn't tell you why. But we squeeze a lot, so we really cared about that.
That makes so much sense. In my head, the only reason I could think of is because now you're so good at major version upgrades, you wanted to give yourself more to do in the future.
Let's rinse and repeat.
Yeah.
Gained it. Yeah.
Nice. All right. So you're running Postgres for a lot of different workloads. Are there any challenges or fun things you wanted to share on that front?
I think maybe a good one just for the audience, and if you're listening out there and you think I'm full of it, please send me an email. Would love to know what you think. But we did the classic Postgres is a queue thing early in our life, and I think that it's on my mind a lot. So a lot of people who have background queuing problems use Redis. When we were at Shopify, or when I was at Shopify, we used this library called Rescue. There's another really popular one called Sidekick. In Node, it's BullMQ. There's a litany of them, right? And they all seem to use Redis. We decided that for our user, who tends to be a front-end dev, or sort of someone who isn't deeply familiar with data consistency or data durability concerns, that we didn't really want to be hey, we'll happily process your background jobs, but we'll drop 0.5% of them and not be able to tell you which ones we dropped and not be able to tell you when it happened. So we for our background queue product, we said it's going to be durable. Not only is it going to be durable, it's going to be transactional, where it's when you kind of do some business logic and you enqueue a job within a transaction, if the transaction commits, then the job will get enqueued, and if the transaction doesn't commit, the job won't be enqueued, and that's the transaction boundary. So we were this is nice. This is us kind of trying to prioritize our customers' sanity, and I think it's the kind of thing that's annoying, because not that many of them are going to notice or care. It's just going to be no data quality issues for this business logic. But that locked us into needing Postgres to be on the hot path for those enqueues, right? We have to participate in that business logic transaction to kind of save the thing. We knew we didn't want to build a giant queue of our own, so we knew we were going to get it into Temporal and let Temporal take over, but we sort of needed a Postgres outbox, if that makes sense, where it's you write to the outbox, and then you're slowly forklifting out of the outbox into the actual system eventually, and then Temporal itself is durable, and so that's the architecture we went with. But as we sort of built it out more and more, we learned about more limitations of Temporal. It came out of Uber, from this system that kind of predates it, called Cadence. And my guess is they learned all this stuff the hard way and built in a bunch of limits that make it, easier for the operators to guarantee certain sort of performance characteristics, but really annoying for people like me. So one of those limits is when you start a job, there's a maximum payload size that's pretty small. I forget what it is exactly. I think it's 50 megs or 5 megs or something like that. And then as that job executes, it can only generate X amount of state transitions, they're called, but events in its processing, where it can only have a certain number of retries, basically, and you need to sort of re-architect your temporal workflows if you want to overcome that. And again, in our case, our users are kind of hey, Harry, I have this 400 megabyte video file that I'd like to process in a background action. Can you just make it work, please? Can you not make me re-architect my entire thing to toss it into cloud storage, whatever. It's ephemeral data. Like, I don't need it in the cloud. I just want to push it to this thing and work it with it in the background. So we found that the temporal limitations were annoying enough that we actually needed to stage a bunch of each job's data outside of temporal. And so we ended up kind of having this nasty hybrid where that Postgres outbox I mentioned sort of became like a store for a bunch of extra stuff. And then the temporal workflow as it went, it would be, transacting with its state storage and doing its state transition things, but then also updating what is now no longer the outbox to be our sort of source of truth. It powered our UI. It had all these extra params, yada, yada, yada. So we weren't even really using Postgres as a queue. Like, we weren't having the classic like skip locked problems and whatever, but we were just having like this sort of like request scale data transmit. Like, one webhook would be one write to this outbox to enqueue, one write to start processing, one write to finish processing. So just like massive tuple turnover. And we also needed to build a UI on this stuff, so we only could get a few of them to be like hot updates. Like, many of them were not. And so we were just like destroying this poor Postgres instance with what I would call like less important data than the actual data plane data, but still important enough that we felt that merited being on a disk. So all that to say, we ditched Postgres for this, and we switched to Bigtable, which is like Google fancy, super distributed key value store. And it friggin' sucks. It really sucks. And the reason is no transactions, right? It's like a way worse model for me as a programmer and a systems designer, and a way more scalable, fundamentally, supersized system under the hood. But boy, oh boy, do I miss the creature comforts, we'll call them, of secondary indexes and transactions and like a sane query language, let alone, the gazillion and one features that a full relational system has over a key value store like that. So we use Postgres, I think, by default for all our workloads. And then when we find something that we're like, okay, I think there's maybe a better fit here, we try to switch it out for the next best thing. But it's like, it's really hard to beat. And I know this is maybe unsurprising on a Postgres podcast, but it's like, I just wish I didn't have to do that. I could have stayed with my creature comforts and got my scale,
Yeah, so I'm curious, what was the number one reason? Is it like bloat maybe, or?
Yeah, it was like bloat, tuple turnover, and just like the fact that we were like always vacuuming.
Yeah, I can imagine.
Another big motivation for switching to something akin to Bigtable is like compute elasticity, where we can kind of, like, Bigtable auto scales by default. You can't even turn it off, I don't think, where they just add more nodes as demand kind of grows. And for us, where we're kind of like the background subsystems are the thing that absorb load, right? When you have a flash sale on your Shopify shop and you need to enqueue a bunch of stuff, like, we need this thing to be able to handle unpredictable surges. And it was a bummer at the time. We didn't have any way to do a zero downtime, like non-disruptive Postgres resize. Now we do, but even then I don't really want to be doing it automatically, like in response to load. I kind of want something like Bigtable that's like 5 seconds later you can get your capacity expansion.
Yeah. Well, I can see it easily. Yeah.
I think like my ideal would be a million tiny Postgreses and have some fancy system for like disaggregating a logical Postgres from a physical VM, where if I have, like, let's say I shard my workload into 16,000 Postgreses, but they only run on 4 VMs, and then as I need more compute, they kind of split out, get bigger and whatever. But that's like a twinkle in old man Harry's eyes. Harry's eyes.
There is work in this direction by multiple teams right now, so we have good
Go on.
Yeah, there is pgdog, there is Multigress, and Planescale also. They're all working in this direction.
And Multigress specifically, it's one of the things Sugu mentioned as well. From his experience at YouTube, he loved having lots of smaller databases, and he much preferred that in terms of reliability and localized outages even. So there were just so many benefits.
Highly automated operations also in the roadmap, like upgrades as well.
And rebalancing,
Yeah. I forgive me for another brief aside, but are you familiar with Azure Cosmos DB? Like the kind of main one, not the Citus one, the main one.
Yeah.
I thought Cosmos was Citus. I get confused by their names though.
So I think there is Azure Cosmos DB for Postgres, which
Okay.
is Citus, but I
Okay.
think there's, and I'm not deeply familiar, so I might be totally wrong here, but I think there is a different original Cosmos DB that's kind of the Azure answer to Dynamo and Bigtable. Like they're kind of like super scale, sort of less sophisticated query patterns, but guaranteed scale for whenever. The way that it works, or the way that it scales, is you specify like a partition key with every piece of data, and you're only allowed partition local transactions. So it's not like a spanner or a cockroach where the whole key space can be transacted against together. It's just like a million tiny partitions, and then every partition could be a max of 50 gigs. And to me, that's like so desirable because it means like one little part, you get like node local performance, but the same horizontal scaling properties of the kind of superscalers, but without necessarily two-phase commit or Paxos or whatever. And so I'm like kind of hoping someone manages to do that. I think it's maybe what's it called, Neki, like the Vitesse for Postgres. Did I get that
Yeah,
right?
that's it's Neki. I have no idea how to pronounce
Yeah,
it.
same. I have no idea. But I'm hoping that's what it is, which is like tiny little boundaries that force me to design my data in a way that makes the transactions efficient, where you don't need a bunch of computers to agree on a transaction outcome, and instead you can just funnel them to the right place.
Unfortunately, they all, not all, but many of them came to me and asked, have you used 2PC? I said, no, I always avoided it, but so they need it, unfortunately. Of course, like some workload will avoid it, but some workload will still need 2PC. This is the sad truth.
Totally.
Yeah.
I think like I used to work at Shopify circa, I don't know, 2012, 2013. We were running like a MySQL fleet at the time, and we felt constrained by the biggest database servers we could buy. Like we were sharding, but it was still like the biggest customers could push the one instances, I don't know what it was, probably 64 threads, like to the max. I'm not really feeling that way anymore. Like I feel like there's few workloads that don't have a natural partitioning where you need more than one server's worth of compute just to satisfy one partition's worth of work. I mean, maybe you talked about this with Simon last time, but it's like you can always split it up. And when you split it up, like you need an aggregate many computers, but one transaction boundary doesn't need, more than one. And so I'm just, and like the hardware has just gotten so much better in that 10 years that I'm not sure I could grow my company fast enough to need that, right? It's like maybe if we had like a graph problem, maybe if we were Facebook or whatever, but as it stands right now, like,
that's true. And on GCP, if we don't look at AMD, we look at only at Xeon Scalable 5th generation, the best available C4 nodes, I think, right? You can get 192 cores or so, but if you go to AWS, you will have even more, like almost, I think, 800 cores, also the same type of processor, and this is already huge. So you can scale one node.
it's just bonkers. Like
a lot.
that's ridiculous. Yeah.
So
It's a lot of Dogecoins, Sorry, so that was a long-winded rant, but what more can I tell you about that temporal sort of Postgres workload setup thing?
Before we started, you mentioned one of the most interesting things you're working on is that you're serving other people's workloads and that you don't control with design, like schemas and design decisions that you don't control. And how do you stay sane while doing that? And also, what are the interesting parts of that?
Great question. You hit me with the question that just invalidates my entire prior rant, which is like, you can partition your workload if you think hard about the schema design, but yeah. So, okay, let me set the stage a little. So Gadget's like reason for being, like the reason why we're working hard on this thing is because we kind of believe software development is still hard unnecessarily. That like when you go to spin up an app on the weekend or your next big business, or just like solve a small problem in your life with software, you spend a lot of time on what we call like baloney problems of provisioning infrastructure, setting up connection poolers, like worrying about the auto vacuum schedule, so on and so forth. We just think that's all a distraction from actually building something useful. It matters, like you can't ignore it, but you also ideally don't want to have to deal with it. So similar to the people who came before us, like the Firebases of the world, we kind of want to delete a bunch of those problems from our customers' lives, take them on ourselves, and allow them to focus on whatever unique, interesting custom problem they want. Like recently, it might even be allow Cloud Code to focus on whatever unique, interesting problem they want, right? But like by kind of deleting infrastructure foot guns and systems integration, we just let people kind of succeed faster. And then I guess I should say, bearing in mind the audience listening here, it's not for everybody, right? Like if you have the perfect knowledge of the Postgres schema you want, Gadget's probably going to be less efficient than that, right? Because we've had lots of layers of abstraction. We have our own operations and infrastructure team kind of managing this stuff. So I'm not trying to say like no one needs to care about these problems. I'm just trying to say that a lot of people, I hope, don't have to care about these problems, so that me and my team, pull our hair out stressing about them. All this means is there's this tension between asking the developer to be more specific about their data access patterns and adding friction for them to, like, on the path to success, right? That, like, every time you say, do you want 4, 8, or 32 bytes for this number, you're posing what I would call computer baloney question, rather than like it's just a number, like, screw off. I don't know. I don't know how big it's ever going to be. Just you figure it out, So in Gadget, we have like a number field type instead of an int and a float and a decimal. We've taken this to a pretty intense extreme where when you do data modeling in Gadget, you specify tables. We call them models because they include behavior as well. But you specify tables and you specify fields. You can specify relationships among them, but you don't run any SQL to realize those schemas. And then you get a kind of fully auto-generated GraphQL API for interacting with those tables without doing anything else. You specify your schema, you get the API. We generate a nice client for that API, we generate nice docs for that API, but the idea is, like, you say to-do, title, string, completed Boolean, and now you immediately can write some React code for a form, or you can ask the AI to write some React code for a form to, like, transact against that stuff. All this to say, we're responsible for the SQL or the schema of those tables under the real tables under the hood, as well as the SQL that API generates and executes. So this is a win because we can avoid things like the N+1 problem. Like, we know how to do that good. We can implement things like zero downtime cutovers or kind of maintenance modes where we know how it's like, this app is in the process of being moved to a different shard. Like, hold on a second, we'll finish that and then serve your request. It's powerful that Gadget sort of owns the whole stack. Oh, we can implement other stuff like cloud storage where you can store data blobs in the right way instead of within Postgres. But it means that all we know about a given application is like what we've collected from the developer, which is, that list of tables, the list of fields on the tables, and the relationships among them. Not stuff like, this is a shard key, or this is how I intend to transact, or if I'm going to make an HTTP call in the middle of my transaction, like 2 days from now when I change my code. So we picked this bed and we made it like on purpose. And it's the idea is we want building high quality software that scales and like meets the demands of Black Friday, Cyber Monday to be more accessible, to not be locked behind, whatever, between the three of us, 60 years of Postgres experience or something like that, right? You should be able to build and get an app going way faster without that. So the gist of it is we need some way to structure our data under the hood within our Postgres such that people can't like take down the platform. They can't use more than their fair share. We need to be safe by default, where we're committing to serving this API, and regardless of what strange queries you throw at it, strange transaction patterns, poorly written code, either out of ignorance or malice or whatever, just needs to still work. Same as like a Firebase or those other companies I mentioned before. And the way that we do that is like kind of two main ways. We don't give everyone their own instance and say, it's your job, like you manage the performance. I think that's what, say, like a Neon or a Supabase does, like, which is still helpful, but it's different, right? They're sort of saying, like, you get this much resources, and within that, it's up to you to optimize. We don't say that. We charge like, kind of by operation, sort of more like usage-based, like, say, an Upstash, Redis, or something like that. And then we consider ourselves, Gadget, on the hook for the performance of those operations. And that means that, again, like, we have to find some way to, like, not process queries that could take us down. So we do two things. We refuse to execute a query unless there's an index on the predicates. and that's just a safety, like, must, basically. We can't run unindexed queries because we can't know that they'll process fast enough to be safe to run at scale. And then we rate limit. And that allows us to say, like, you know, no one can have more than their fair share. But the crazy thing is, almost no one hits their rate limits. We consider that like a regrettable private platform protection mechanism, as opposed to like a pricing mechanism or like an incentive. And the reason that no one hits their rate limits is because if you just force every query to be indexed, like, you get pretty far. There's the planner is so good, and like the bitmap index combining stuff gets you so far that, like, almost nobody, or anytime we ever have like a database CPU spike, it's usually because something's gone wrong with our creation of the indexes. Like Gadget's automations, their temporal workflows, surprise, like, have failed to set the index up properly, or we like let the code that makes the API calls ship before the index was actually in place, or something like that, you know. But it's like Postgres just works if you do this. So it's really naive, but it works.
Are you okay to share how many indexes you've already created?
Yeah, we have, I think, probably over 2 million indexes in our system right now. Actually, sorry, I take that back. At the time of the sharding, we did, but it's we've reduced that drastically since then, but for kind of unrelated reasons. But yeah, basically, if a user wants to be able to, in their API, sort or filter on a column, we just say there has to be an index. And so we have, like, I don't know, most of the columns indexed. And like, oh God, I can feel the hate mail now, talking to a giant legion of database engineers who are all screaming in their cars right now. Why do you index every column? No. The modern hardware that respected Nick just mentioned means that, like, the cost of this, while substantial, is not actually that crazy. Like, it's higher, no doubt, but we're not in the days where you need to be so incredibly stingy about every index you make, especially when the cardinality of the tables are like, you know, 1 million, 2 million records, as opposed to like 10 gazillion, right? When our first 10 gazillion customer comes along, we're going to work with them closely to be like, you don't need that index. Like, let's turn that off. Your stuff will go faster. But the vast majority of people, the overhead is it adds up, but it's not so meaningful that our business is busted, you know?
Yeah, so I wanted to say that this is a pet versus kettle philosophy. If we like think about indexes as a pet, we need to get rid of unused indexes, take care of bloat, and all. But at your scale, before schema became sharded, millions of indexes, you think about this as kettle as well, just inside one Postgres instance, right? Before it became sharded.
Yes.
So
yes.
This is interesting approach, and I agree with since we have small tables. We know if there is right amplification, all indexes, if it's not hot update, it needs to update all those indexes. Some of them are not used. But since approach by design, it's kettle, okay, it's not that bad.
Yes.
This is interesting case.
Yes.
I must say I never saw it before. So it's interesting.
Absolutely.
I've heard of one other case, which was Heap Analytics blogged about. Something about, yeah, you know the one, great.
I sure do.
So that was the only other time I heard about this.
Was it also where they discussed that they create indexes without work concurrently, right?
Yeah, because you can't do more than one at the same time.
Yeah, to parallelize work.
Yeah. Mm-hmm. What's neat or strange or weird about Gadget is we kind of participate in the whole SLDC, like the whole life cycle of, like, authoring a feature, debugging it, deciding it's good, merging it, and deploying to production. Gadget has a development environment as well as the production environment. And so we kind of get to witness the moment that you want to go live, and we just do a normal style, call it Rails or whatever, like, migration where on deploy we like create the indexes concurrently behind the scenes, then we ship the code that makes use of them, and then it's like we can do that because we're not sort of exposing the raw SQL and asking people to manage their own schema, so on and so forth. But what do I want to share about this that I think is the most? Oh yeah, so the first thing is like giant catalogs where you have, we had, I think at peak in one instance, like 250,000 tables, 1.4 million indexes. Giant catalogs like suck, but were more manageable than I was guessing. Like I was assuming there was going to be some like ON squared system table inside Postgres, or like some doinky little thing that just breaks when things are that big. But no, like that instance operated well. The thing that did break was a bunch of the analytics tools out there. Like
PGStat statements.
PGStat statements was okay.
Okay.
It was big. It takes a lot of data, but it wasn't like an ungodly amount of performance overhead. But like PG Analyze and many of the kind of collectors, they're like, let's get the size of every table every minute, And it's like that's a hard no.
Our monitoring also didn't work properly because of catalog.
Yeah, but you guys only had to make a couple tweaks. I think we're talking about PG Watch 2, like the Postgres.ai remix, and it works well for us. It's the kind of fastest one. I haven't tried PG Mustard, but I must.
It's not a monitoring tool.
Yeah. It's all right. It's all right. So that was surprising, but the other, actually, this is just a fun fact. So we did our sharding. We moved this gazillion number of tables over to Alloy. We turned on their analytics thing. It's called Advanced Query Insights, and it's not bad. Like, it's a nice UI for kind of PGStat statements souped up a bit. They store all the data for it in a private database in your instance. So like you have an almost super user, but not a full super user, and there's this one database you can't touch that has it in it. And currently, this is my fault, I like set it all up, and I was like, oh, this is probably going to be not that expensive. Currently, our like AlloyDB Insights database is almost 1.5x the size of the actual database. And I think it's because the query diversity is so high, and all the like data that they're keeping about each one adds up so much that, yeah, we're paying more than double in storage just for the privilege of this thing, and half the like queries time out. But again, I'm going to blame me for that, like not Alloy for that. We just need to turn that off.
I'm curious if the main, like if we have just one AlloyDB database and we store metrics inside the same thing, if it's down, how we will troubleshoot?
I think it is only like query insights, like the equivalent of PGStat statements
for troubleshooting.
I guess you're right. I don't know.
So isn't the same true for Postgres, like with PGStat statements?
Yeah. But that's why we need external monitoring tool which will pull data and store it independently for troubleshooting. I thought about this like self-observed or externally observed system. I think we actually need both. But if it's just self-observed, it might be a problem.
Yeah,
sometimes.
It goes full circle to that same thing we were talking about with the infrastructure provider earlier, which is like they don't have anywhere else to put it unless they're going to pay for it, right? So by putting it in my instance, I pay for it, which I am paying for dearly, and I'm now going to turn off, But I agree. You do get the like system metrics that they store in their fancy
external
time series database, but yeah.
Mm-hmm. Yeah, I didn't know about this. Interesting.
Yeah, I think if I may, the most interesting thing we've done to manage this ungodly number of indexes and tables is classic computer science, a hybrid strategy. What we noticed is like many gadget apps are like tutorials. It's like someone wants to kick the tires, or they're building a to-do app and they only ever add 3 to-dos. It's kind of excessive to create them one to-do table, one user table, indexes on many of those columns to store 0 to 5 rows. So we use a thing we call a storage strategy pattern, where different gadget models are backed by different data. We still store them in the same Postgres, and that's so that we can still transact against them together. Like we support, real, actual Postgres transactions, but we use doinky little JSON-B tables when the cardinality is small. So we like have one, we call it shared JSON table, which has like an ID, a model identifier, and then just field values, and we don't index that at all. No gin, no nothing. We just kind of do a table or you could call it a table scan, even though it's not. It's like a range scan. But and then we just bound the cardinality of that. And then when we witness the, I think it's like 22,500th record, we swap out kind of a real table that has the real indexes and whatever. So that cut our table count and our index count down by a lot. Again, that swap is zero downtime, and it has to be. Like, that's again our commitment to our customers, and that was actually quite difficult. In order for like someone's doing a bulk load of data or whatever, we witnessed that 2500 record, we have to kind of like pause traffic, do the switcheroo, resume traffic without like there'll be a latency spike but not an error spike. And I think that's kind of, it's Gadget is a bundle, right, where we have this back-end runtime, this front-end runtime, this database, like all these things that work nicely together. And we see that as validation that the bundle's showing through, where it's like we can only do that because we have kind of control over the app tier, control over the load balancers to be able to be like, hold on a second, we got to do some maintenance on your app real quick. We won't drop any requests. We'll do a little, switcheroo without anybody knowing, and you're off to the races with the sort of full performance after that.
That's a really neat trick. I like that. But you must have lem provisions in that code that doesn't allow queries without indexes to like account for tiny oh my goodness, this sounds painful.
We've been working on it for like 4 years, so yes, but I think we're in a good position. Like, I'm excited for BFCM this year, which for operations staff is, I think, a rare thing to hear. Like, I think I'm excited for the challenge,
I saw the color drain from Nikolai's face.
Yeah.
Do you think there might be some point that True Postgres will be fully replaced in your company by something, or there will always be a place for True Postgres, not AlloyDB Postgres-like database system? But...
Great question. I think yes. Like, I do think it will be fully replaced, and I think it's only because we haven't seen any Alloy downsides. Like, while it's a fork, it's still 99% True Postgres. So we have like PG Vector support, for example, and PG Squeeze support. It's not like a wire compatible thing. It's like mostly actually Postgres with the like wall and the block storage kind of ripped out.
It also has lightweight locks and so on, all those problems.
Yes.
Yeah. Bloat.
Yes, true. I think like the thing, like, I think we're going to stick on Alloy, but like not because it's the very best, but because now we have familiarity. Now we know we can maintain it. Now we can scale to Valhalla. So we've sort of unlocked something, and we've got other stuff to do. I think the thing that would make me revisit that is Oriole DB or whatever InnoDB for Postgres is. Like, when that comes around and I don't have to vacuum anymore, that seems like a pretty epic win that I'd be interested in realizing.
Makes sense. Yeah.
Great answer.
Yeah.
Great. Thank you so much. Enjoyed. Learned
Thank you
something
guys.
new.
I really appreciate getting to nerd out. These are the things that keep me up at night. Of like 1.4 million indexes. What do I do? So it's nice to let it out a little bit.
Yeah. Cool. Thank you.
It's our pleasure. Thanks so much.